Hi, welcome to Sciprex. In today's video, we will explore on .NET Developer. A short recap on .NET Developer. A .NET developer is a software professional who specializes in building, deploying, and maintaining applications using Microsoft's .NET framework. They work with programming languages such as C# and VB.NET to develop web desktop and cloud-based solutions. Net developers are proficient in using Visual Studio, ASP.NET, and related technologies, and often integrate databases like SQL Server. Their role involves writing clean, scalable code, debugging, and ensuring application performance, security, and maintainability. Here are some friendly professional interview question and answers. Q1. Can you describe your experience with the .NET framework and its components? Answer. I have extensive experience with the .NET framework, including ASP.NET for web applications, ADO.NET for data access, and Entity Framework for ORM. I have used both .NET Framework and .NET Core .NET 6 Plus for developing scalable web applications and APIs. I'm comfortable working with Visual Studio, managing dependencies through NuGet, and integrating services via RESTful APIs. Q2. What is the difference between .NET Framework and .NET Core/.NET 6 Plus? And when would you choose one over the other? Answer. The .NET Framework is primarily for Windows-based applications, whereas .NET Core and its successors .NET 5 and .NET 6 Plus are cross-platform, open source, and optimized for performance and cloud deployments. I would choose .NET Core .NET 6 Plus for modern applications that require high-performance containerization or cross-platform support, and .NET Framework for maintaining legacy systems running on Windows. Q3. Explain the role of the Entity Framework in .NET applications. Answer. Entity Framework, EF, is an object relational mapper, ORM, that simplifies data access by allowing developers to interact with a database using .NET objects. It eliminates the need to write most SQL code manually. EF supports link queries, change tracking, migrations, and ensures data consistency through model validation. I've used EF Core in several projects to streamline CRUD operations and maintain a clean separation between the data and business layers. Q4. How do you manage exception handling and logging in .NET applications? Answer. I implement structured exception handling using try-catch blocks, and I ensure meaningful error messages are logged without exposing sensitive information. For logging, I use frameworks like Serilog, Nlog, or built-in .NET Core logging providers. I also integrate logging with external systems such as Azure Application Insights or ELK Stack for centralized monitoring and diagnostics. Q5. Can you describe a challenging project you've worked on using .NET and how you address the complexity? Answer. In a recent project, I was tasked with migrating a monolithic .NET Framework application to a microservices-based architecture using .NET 6. The main challenge was refactoring tightly coupled components and managing service communication. I introduced REST APIs with minimal coupling, used RabbitMQ for asynchronous messaging, and implemented API gateways for routing. This approach improved scalability, performance, and maintainability significantly. Q6. What is the difference between asynchronous programming using async await and traditional multi-threading in .NET? Answer. Async await in .NET simplifies asynchronous programming by allowing non-blocking operations without managing threads explicitly. It works on the task-based asynchronous pattern, TAP, and improves responsiveness, especially in I/O-bound operations. Traditional multi-threading, on the other hand, involves manually creating and managing threads using thread, thread pool, or task run, which is more complex and resource-intensive. Async await uses a single thread efficiently through continuations, whereas multi-threading is better suited for CPU-bound parallel processing. And Q7. How does dependency injection work in .NET Core? And how would you register different service lifetimes? Answer. Dependency injection (DI) in .NET Core is built in and configured through the I service collection in startup.ccs. It helps manage object lifetimes and dependencies more cleanly. Services can be registered with 3 lifetimes. Singleton, a single instance throughout the app. Services.addSingleton. Scoped, a new instance per request. Services add scope. Transient, a new instance every time it's requested. Services add transient. This promotes loose coupling, better testability, and cleaner architecture. Hope you like and subscribe this video. Don't forget to click on bell icon. Thanks for watching Sciprex. Keep learning and stay inspired.